Right. The next topic we will discuss about is DHCP, which is Dynamic Host Configuration Protocol. DHCP is used to automatically assign the IP addresses to your computers in a LAN. So how does DHCP work? So let's say you have a computer or a machine that you power on, maybe connected via LAN or connected to a Wi-Fi. What is the first thing that happens? It needs an IP address. So if the client machine has been configured to get IP address via DHCP, then it needs to figure out how to get that IP address. By default, the client machine does not know where is the DHCP server. So maybe DHCP server is sitting somewhere here. Let's say this is the DHCP server. So, but the client machine doesn't know that there is a DHCP server and what is the IP address of that DHCP. Now, how does it figure it out? So the client sends a discover packet trying to discover the DHCP server. The DHCP server listens on port UDP 67. When the client sends the discover packet, this packet is initiated from the client machine using a source port of UDP 68. So the client machine creates a packet. The layer 4 information in this packet will have a source port of UDP 68 and destination port 67 UDP. Right? Now the layer 3 information in this packet will be layer 3. We need information for all the layers because the packet formation will move down the layers on the sender side. So when it moves down the layer from the layer 4 goes to layer 3. On the layer 3 needs to add the source IP and destination IP, right? But right now this computer does not have an IP address. We're trying to get an IP. So what will be the source IP? Because there is no IP address assigned to this machine at this moment, so the source IP will be 0.0.0.0. And the destination IP, do we know the destination IP of the DHCP server? Well, DHCP server does have an IP address assigned to it. Maybe that is 192.168.1 dot something, but the client doesn't know that what is the IP address of DHCP server. So if it doesn't know the IP address of DHCP server, while sending that discover message, what IP address do we put in? So it sends that as a layer 3 broadcast. So the layer 3 broadcast is all 255, 255, 255, 255, 255, 4 times. That will be the destination IP. Then it moves to layer 2. On the layer 2, we add source MAC address, which is the MAC address of this machine, which the machine is aware of, and then the destination MAC address. So again, we don't know the destination MAC address of the DHCP server, so the destination MAC address will also be a layer 2 broadcast. So it adds a broadcast MAC address, FFF. Now we have all the information required to send this message. So this is how your discover packet goes out. In your LAN, it is possible that you have a switch, and that switch will, because it's a layer 2 broadcast, the switch will send that packet out through all of its interfaces. On some ports, there will be some computers connected, which will eventually drop this packet because it is not for them. The destination port in that packet is UDP67, which the machines will not be listening at. Only the DHCP server will be listening on port UDP67. So when that gets delivered to a DHCP server will look at the layer 2 information that it's for a broadcast MAC address, for a broadcast IP address, but when it goes to layer 4, then it checks that this is for a DHCP server who is listening on port 67. So then the DHCP server replies back. The reply from the DHCP server is known as offer. So the DHCP server then sends an offer. This is sent by server to client. So now the DHCP server, whose IP address was 192.168.1.5 and whose MAC address is probably B, there was a client who requested for an IP address whose MAC address was A and did not have an IP address. When the DHCP server sends an offer, so on layer 4, it will put some information. Layer 4 is transport layer, so it will have source port and destination port. The source port of this packet will be the DHCP server listens on UDP 67. So because this is initiated from the server side, so the source port will be UDP 67 and destination port will be UDP 68. Okay. Then we go down to the layer 3. The layer 3 will have source IP, which is because it is being initiated from the server now, the server has an IP address, so the server will use its own IP as a source IP, 192.168.1.5. And the destination IP, so we don't know the destination IP yet, right? The destination does not have an IP address. This will be a layer 3 broadcast again. Destination IP will be a broadcast IP. Well, this may be a unicast IP. It really depends. In the discover packet that was sent by the client sets a flag there, which is boot P flag. So if client sets this flag to 1, which means the client is expecting the reply as a broadcast. If this boot P flag is set to 0, so the client is expecting a unicast reply. With 1, it's expecting broadcast, and if it is set to 0, then the client is expecting unicast reply. So when the boot P flag will be set to 0, it's telling the DHCP server that you need to send me a unicast reply. So how will the DHCP send unicast reply? The client doesn't have an IP address, so how will it send a unicast? Well, in that case, the DHCP server sends the reply to the IP address that it is going to offer to the client. So maybe the DHCP server is going to offer an IP address 192.168.1.110. So it puts that as the destination IP and sends it to the client. Right. So that's the role of the boot P flag. This boot P is available in the discover packet sent by the client. So this decision is made by the client. The client tells the server how it is expecting the reply. In most cases, you will see that the offer destination IP in the offer packet is broadcast because that's what the client requested. So then we continue to layer 2. On the layer 2, we'll have source MAC address. Right now we're talking about the packet that is being initiated from the DHCP server. So it will have the MAC address of the DHCP server. And then we'll have destination MAC address. So in the destination MAC address also, the server will still use the broadcast. So it will be layer 2 broadcast again. This packet then goes to the client. There's one more thing. The most critical piece here is that this offer packet will have the IP address that the DHCP server has to offer. So that information will be added to the payload. Payload is the part which contains the actual data. So in the payload, the DHCP server will give the IP address. This is the IP that you can use. That IP address will look something like this, your IP, and it will give it put that IP there, maybe 192.168.1.110. Along with the IP, the DHCP server will also provide subnet mask, the default gateway, the DNS server that needs to be configured on the client, right? And it also adds the client's MAC address in the payload so that the client can verify the MAC address that this packet was destined for you. Let's take a look at the Wireshark capture. So far we have talked about discover and offer packets. So I happen to have a capture here in which you can see there's a discover packet sent from the client. You look at the source IP here. The source IP is 0.0.0 and destination IP is a broadcast IP, right? That is a DHCP discover. And when you look at the boot P flag that I was talking about, it depends, the boot P flag decides what will be the reply packet. Will it be a broadcast or unicast? Right now this is set to 1, which means broadcast. And you see in the next one where the DHCP server sends the offer. So that is the IP address of the DHCP. When it sends the offer packet back to the client, the destination IP is broadcast because that is what the client requested for. Let's check the DHCP offer now. In the DHCP offer, the DHCP server offers the client an IP address, which here is 10.38.148.31. Then it also sends a subnet mask, default gateway, the release time, and all those things here. If there is a DNS server that needs to be configured. So all those details are sent in the offer packet by the DHCP server. right? Then we have DHCP request. The server has offered an IP address, but at this time, the client still does not assign that IP address. So the client PC, the client machine makes a request to the server that, all right, I'm going to use this IP address, so if you can assign it to me. So for that, the client sends a DHCP request. This DHCP request goes from client to the server. With the help of this DHCP request message, the client is making a request to assign the IP address that was offered to it. So on the layer 4, we'll have the source port as 68 because it is being initiated by the client. Destination port will be 67 because that is the port that the server is listening on. Right? Layer 3 information will have the source IP because the client currently does not have a source IP. The source IP will remain 0.0.0. Destination IP, so destination IP will still be a broadcast. And we'll have layer 2 information, which will have the source MAC address. So that's the MAC address of the client machine, which is known. And then we have destination MAC address that still remains the broadcast. And in the payload, the client will put the IP address that it is requesting for. So that it pulls that information from the offer packet that I'm requesting for this IP address. For example, 192.168.1.110, right, which the DHCP server offered in the offer that it sent. This DHCP request goes to the server, and then the server sends an acknowledgement back that, all right, you can use this IP address now. So when the server sends the acknowledgement, the server sends it back to the that acknowledgement packet will also be a broadcast because the client hasn't yet assigned the IP address. So then we have acknowledgement that is from server to client. On the layer 4, we'll have source port of 67 because that is the port the DHCP server is listening on. We have destination port as 68. Right. On the layer 3, we will have the source IP, which is the IP address of the DHCP server. As an example, we assume that it is 192.168.1.5. And then we have destination IP. The destination IP will still be a broadcast because that is what the client wanted the DHCP server to follow based on the boot P flag there, right? On the layer 2, we'll have source MAC address. So source MAC address because this is being sent from the DHCP server to the client. Source MAC address will be the MAC address of the server, and destination MAC address will still be broadcast. In the payload, the actual data of this acknowledgement will contain the IP address that the DHCP server has offered. So it will have the your IP 192.168.1.110, and it will also have the client's MAC address just to confirm that you are the right client receiving this